Hello everyone and welcome back to Post Network Academy. I am Bindeshwar and today you are going to learn one of the most practical and beginner friendly algorithms in all of the machine learning, K nearest neighbors or KNN. KNN is incredibly versatile. In this session we will explore two powerful applications of KNN that every data scientist should know. First, we will use KNN for classification to predict the type of a flower based on its measurements. Basically, we have used iris dataset. Then we will apply KNN for imputation to fill in missing values in a dataset using nearby data points. So without further delay, let's get started. So KNN is a supervised machine learning algorithm, and it is easy to understand and does not involve complex math compared to other algorithms. It is commonly used for classification, especially with labeled data. We will use the iris dataset which has flower measurement. So iris flower types, the first one iris setosa, its petal is here, like here, and sepal here. Iris versicolor, petal and sepal. Iris versinica, petal and sepal. So based on this petal and sepal length and width, we will train the model and we will predict the class of data for an unknown level. So iris data set sample features. It includes sepal length, sepal width, petal length and petal width. And the target class is the iris flower type, Setosa, either Setosa versicolor or versinica. And you can see that basically original data set has 150 instances which has 4 features and 1 label, but for the sake of simplicity I have taken only 10 instances in which 9 are labeled. You can see that here 9 are labeled and 10th one is not labeled. 9 instances will be used for a training and 1 will be used for a testing. We will test that what would be the label of the 10th one. So that is basically a typical supervised learning problem setting, and this problem is classification problem. So what will we do? We will calculate distance and we will use Euclidean distance. So here sepal length of first instance minus sepal length of 10th instance square, because SL is sepal length. Sepal width of first instance to 10th and you will square. So finally you will get the distance between instance 1 and 10, that is 0.424. The same way I have calculated distance from other instances, and distance from, you can see that here itself, that is 0. So then KNN works on similarity. So if we take k is equal to 3, the 3 nearest distances are all iris setosa. So if k is equal to 3, the majority iris setosa instances are nearest to instance number 10. So we can tell that instance 10 is iris setosa. Now let us see how to implement it in Python. So import the KNN model from scalar. So here I have already written whole program knn.py. So we will import this one, and thereafter second step, create 9 training samples with features like sepal and petal measurements. So see that here Here 9 instances I have created, and now I have put in a list. So extrain list inside list. So that will extrain will be have like a table. So there are, you can say that, 9 training samples with features like sepal and petal measurements. And thereafter, what we'll do, we will assign class level iris setosa, iris versicolor, iris virginica. So here class level, here iris setosa, iris versicolor, virginica. Basically that will map this one to this one, second one to second one, third one to third one, and thereafter we will assign. So I1 is iris setosa, I2 is iris setosa, I3 is iris setosa, I4 is versicolor, I5 is versicolor, I6 is versicolor. Here now, thereafter we will initialize the model with 3 neighbors and Euclidean distance. That means neighbors is equal to 3 and distance, Euclidean distance, because p is equal to 2. So we have done here. Thereafter train the model. So fit method is used to train, and thereafter we will predict. So here you can say that fit model, and thereafter we will predict. And which method we will use? Predict method. And we will pass this two-dimensional list into predict. And when we run, so we will get the result. So let us run it. What is the class of that x unknown? Right? We will predict class for this instance. So let us run it. So you can see this iris setosa. So what you should do, you should take some more data from iris csv.csv file, and you should train on that data, and also experiment with number of neighbors and see that what are result. So this was simple example of k nearest neighbors. Now let us understand what is a KNN imputation. So basically it is a technique to fill missing values using the k nearest neighbors. And in the last video I explained about missing values. So if you don't have idea about missing values or imputation, so you can watch that video. So distance is calculated using available features, and that would be Euclidean. The missing value is imputed using the average or most frequent value among neighbors. So we will see that suitable when patterns exist in similar rows. Now let us consider the following data. So this is the ID. Basically data has three features: height, weight and age. And in height this value is missing. So how will we fill it and impute it? Let us see. So first of all, rows 3 is missing a value in height. So first of all we will calculate distances using known values, weight and age. So row 3 has, you can say that 3 like 62, that is the value, and 28 is age. So we will compute the distance to other rows using weight and age, only two features. So when nearest neighbors, if we see nearest neighbors, so that are rows 2 and 4. So what will we have? So we will take height of neighbors here. So here, so let us see that here This is instance number 4 height and instance number 2 height and instance number 4 height. Let us, so that is instance number 2 height and 4. Okay, so what you will do, just you will take average of them and you will fill it. Let us see that here. So these two are nearest neighbors here, and what you will do, you will take this height 165 and 170 and you will fill this value with these two averages, means nearest number. Nearest means you have to calculate using KNN, not like just 2 is closest, not. It may be instant 5, 6, whatever. So the missing height has been filled with KNN with k is equal to 2. If you take 3, you have to take average of 3. 4, so 4. Now, KNN is effective for datasets with structured patterns. Choose an appropriate k based on data set size and similarity, normalized features. Now, let us implement KNN imputation in Python. So, import libraries pandas, numpy, and KNN imputer from scalar. So, here I have written already the program. So, we will import. Thereafter, prepare the data set using the dictionary in Python. Dictionary inside list. Thereafter, pass this data into pandas data frame. So, you will get pandas data frame. So, thereafter, drop the column ID is ID column because we don't need. Thereafter, you can see that n is equal to 2, that means 2 neighbors and metric non-Euclidean. Thereafter, just train it and it fit transform will, you can say that train, or you can say that fill the value. Now, imputed data frame is here and imputed array is here. Thereafter, insert the ID again and thereafter print that one. So you can print. So without further delay, let us print it here. You can see that earlier it was here. This one is you can say that pandas index. You can remove. 3 features are main. So you can see that not a number. Now it has been filled by 167.5 for a k is equal to 2. You can experiment by k is equal to 3, and we can also experiment. Let us see. If I take k is equal to 3, and we have to change here k is equal to 3, otherwise here. So let us see, and also clean the output screen and run it. So we will see that for a k is equal to 3, okay, for a k is equal to 3, it is 165. So you can experiment. So KNN imputer is a method which is used to fill missing. So hope you have understood. For more resources, you can visit website, YouTube channel of Post Network Academy, Facebook page, LinkedIn page, and GitHub repositories for the code. So hope you understood. Thanks for watching the video.